everybody. All right, let's go.
You're not there yet.
All right. A year ago this week, my friends Brian Silverman, who's behind most every release of Logo since the 1970s, and Eric Nauman from the Hewitt School, and I developed a new version of the Logo floor turtle called LogoTurtle. We've since used them in a number of different schools with middle and high school students, and have developed some interesting theories about mathematical knowledge that the students have developed through the use of the LogoTurtle. According to Brian Silverman, for better or for worse, the idea of mucking around in programming is for better or for worse, not very popular in grown-up computer science. Computer science has become an engineering discipline where you do things right the first time. Logo programming has always been about debugging. Before the do it right stage, there's always been dozens, if not hundreds, if not quite right stages. So when we teach Logo programming, we're teaching people to think about thinking. The goal of learning to program in Logo is to think algorithmically. You program the turtle to express a sequence of designs that express over time. Since Logo is a procedural programming language, you make small tools. The serendipitous discoveries made through the ease of block-based programming is a great way to get students interested in programming. Since the blocks come with numbers attached, like write 90, for example, designs can quickly emerge, but we risk shallowness. The LogoTurtle is a great STEAM project that uses 3D printed parts and microcontroller, hand-built electronics, and text-based programming to create art through the exploration of math. LogoTurtle is also a project that democratizes robots in schools. When the cost of FIRST puts this project out of the reach of many schools, LogoTurtle can be assembled for about $60 in parts. The 3D printed parts can be printed by a service like 3D Hubs if you don't have a 3D printer, so it costs less than $100 to build. LogoTurtle is a tool that allows you to create work that you would otherwise be incapable of producing. It offers relative precision and repetition using math. The LogoTurtle is also an imprecise tool. The microcontroller can't do decimals, which makes using and calculating pi tricky. The friction of the pen and the wheels on the paper also affect the drawing. So this imprecision adds to the mucking around. Last school year, I started an after-school Logo programming club for 7th grade students, and we progressed from block-based programming in turtle blocks to fabricating t-shirts, to 3D printing our designs, and then assembled and programmed the LogoTurtle. Here's an example of a design that the student wanted, that the student programmed in turtle blocks and then tried to get the LogoTurtle to draw. When he attempted to do the design one-to-one, it just didn't translate. He didn't give up though, he iterated 5 or 6 times. So how often do you see a student get a math problem wrong and go back at it 5 or 6 times to get it right? So each student who I work with at this school iterated until they reached approximated perfection. Instead of looking at it as the fault of the LogoTurtle that could be solved with a better tool, they willingly undertook the exploration of the math and engineering that might get to improving the design and capturing the perfection. So perhaps it meant turning 92 degrees or going 362 degrees to make a circle. Based on my research for my master's degree, I think the perseverance that the students using the LogoTurtle demonstrate is rooted in the aesthetic nature of the challenge, in the freedom of choice, and also in bossing around a robot. LogoTurtle is not an out-of-the-box experience. You have to assemble it yourself, but you have a thorough understanding of how robots work in the end. Since debugging is at the root, mucking around rewards the user, but it does take patience. One of the amazing remixes that got done with it was Aaron O'Reilly at Greenwich Academy, with the help from Eric, remixed a file and made it so we could turn on and off an LED and draw with light. So I also had my friend design a laser cut chassis to make it more accurate because the chassis is more flat, and just design this new bumper to make it a robot that not only can produce art but autonomously explore the room. The build instructions are available online at that URL, so long as you can read and follow directions. It's a project you can expect to finish in about 2 hours. There's minimal soldering. That doesn't include the time to 3D print the parts, which take about 30 minutes each. There's also some prompts available for you, ranging from beginner all the way up to advanced, anything from calibrating the LogoTurtle to programming generative art using the LogoTurtle. So the LogoTurtle is an impressive tool that allows you to create work that you would otherwise be incapable of producing. It's a true STEAM project, drawing from many different disciplines and exposing the builder and user to many different skills. So I encourage you to build one today. Thank you.